So this is my service 1 and this is my service 2. Okay, so now no, service 1 wants to talk to service 2, and if service 2 is actually available, right, it will give you a response back. Look, this call will happen via APIs, right? So I know IP of this, so I know port of this, I know the URL, right? So I'll get the immediate response here. But in a async world, right, so what will happen? I will explain you that. Suppose you have here a bulb, right? So, and this is my mobile app, right? So from the mobile app, I want to control the bulb, right? So I want to make it on or off. Now the bulb is actually, available in my home, right? In one room. Now how these two parties will talk to each other, right? So that's where if you follow use MQTT protocol, so we'll have MQTT broker here. Okay, so MQTT broker, again you can deploy the broker in your home, or you can use a cloud. If you are using AWS or any other cloud providers, you can use cloud broker, or broker is nothing but a small server. Okay, or you can use third party brokers like HiveMQ and all. They provide MQTT broker service, so you can use that. Now suppose the entire communication is actually happens in a publish and subscribe model. Okay, so what is publish and subscribe model? So first, all these equipments, right, whatever equipments I have here in my home, right, suppose I have one more fan, so that has to send a message to the broker. Okay, so what kind of message it will be? Okay, so in a pub sub thing, right, so it is actually communicating via topic. Okay, topic is nothing but a string. You can imagine topic is a string. Now no, bulb, right, so let's say bulb is using a topic, right? Wait, so bulb is using a topic like hall bulb, right? It is publishing the status of the bulb, right? What is the status in this bulb, right? So it can have only simple status, right, on and off, right? So nothing else more than, I mean, in this kind of situation, this is like hardwares, right? So what they can give max to max, like bulb is on or bulb is off. Now it is actually publishing either on or off, right, that status in a particular topic. Okay, now suppose I have a mobile app here, right? How the mobile app will know whether bulb is on or off, right? So mobile app has to talk to, it cannot, it doesn't know where is the bulb is, right? So there is no direct communication between the bulb or the fan and the mobile app, right? So what it will do, it can subscribe for a particular topic. Okay, So it can subscribe for a topic from the broker. So now I want information about all bulb, right? So it will subscribe for that particular topic. And when it will subscribe, right? So once it is bulb is publishing, right? So it will publish, keep on publishing its status on or off to the broker. Now broker will see if we have any consumer of this particular topic. Now broker seen like, okay, one mobile app is consuming this particular topic. So broker will send only these values to this topic. It will not send any other thing like either on or off. So in this way, mobile app will know the status of the bulb. Okay, without even knowing where the bulb is. Similarly, mobile app wants to know the status of the fan also, right? So fan also has to publish in another topic. Okay, so topic should be unique here for each connected devices. Okay, so you cannot reuse topic here. This is the way we identify things, right? So it will be like all fan. Similarly, fan is also publishing, suppose some message like on and off. It can be string or it can be binary values, 0, 1, anything. So once fan is actually sending the message, if the mobile app, same mobile app, suppose subscribing for that topic also, right? Hall and fan, same, whatever is here, it needs the status of the fan. So client can subscribe for multiple topics. Okay, so and once it gets the status, it can actually control it, right? So suppose it is getting a status off, fan is now status off, and from the mobile app I can send another message to switch on the fan. So to implement that again, the other side also has to receive it. Now you're sending like it is publishing, right? So it has to subscribe also. If suppose you want to do the reverse operation, like now it is giving the status, but you want to control it also, like you want to switch it on basically. So what it can do, it has to no publish, subscribe for that. Once now we are publishing, right? Now suppose I want to control it. Bulb wants to control the status of the bulb or fan. So then what the fan or bulb has to provide that facility, right? The controlling facility, right? So it has to so that mobile app actually will having an option to on and off. Now I'm just telling I'm on or I'm off. I have not given like in a facility to turn it on or turn it off, right? So the bulb and fan are now actually publishing, right? Bulb and fan can also subscribe. Subscribe means receive. Bulb has to subscribe, and whenever you are sending on, it can actually perform that operation. You can, there is no limit on how many devices you can connect in this model. No, and it all depends on your the broker limit. This is called pub-sub architecture, publish and subscribe architecture. This is completely async in nature. Okay, suppose bulb is off now. Something happened, that communication got broken, right? And mobile app wants to see the status, and it is then broker should be able to tell the mobile app like, no, this is offline. And then whenever last message received, suppose the bulb is offline now, 9:30 bulb is offline. Okay, and then 9:31 bulb is becoming online. Depending on the again some of the implementation stuff, like you can retain messages, last retain message. So if that is enabled, then the last message which is coming from your subscribe clients, you will the broker will deliver. Because in IoT kind of this thing, right? So these devices can be offline at any point of time, because it depends on the network, right? Bandwidth and all, right? and those are small devices, right? So memory will be always, a constraint, bandwidth will be always a constraint. Suppose you have another application here, cloud application or web application, okay, and this application's no responsibility is to monitor all these things, like how many devices are connected, how many are online, how many are offline, right? And trigger maybe alerts and all to needed parties. Okay, so from one place you can, it has to then subscribe for all, and once it gets all the messages, you can see in a dashboard kind of stuff, like the real time monitoring you can do of all the connected devices. If any suppose if any device gone, no, it's not working basically, and you want to reboot, right? You reboot that bulb. So you should be, if you have a permission, like you are an admin and you are monitoring everything, you should be able to trigger a reboot command, right? But if it is completely, line is completely off, the connection is completely broken, then you cannot do anything. But once that is restored, right, connection is restored, you should be able to start from where you left last. Suppose you are traveling, okay, I'll give you another example. You are traveling in a smart car, okay, and you are receiving the GPS may, you are receiving information, right? You are completely connected, and you encountered one tunnel in the road, right? So that is a big long tunnel. So once your car went inside the tunnel, your connection is lost basically, right? So you will not get any messages. So but by the time you move out from the tunnel, right, so and you re-establish your connection, depending upon your connection type, right, you can actually select what kind of connection. I know you want a persistent session or you want a new session. Suppose you have selected persistence session, right, while connecting to your broker, so your connection will be automatically restored and you can start from that point of time.